Question 2, Part C. The points P, 2AP, AP squared, Q, 2AQ, AQ squared, and R, 2AR, AR squared lie on the parabola x squared equals 4ay. The chord QR is perpendicular to the axis of the parabola. The chord PR meets the axis of the parabola at U. The equation of the chord PR is y equals half times P plus R in brackets times x minus APR. The equation of the tangent at P is y equals PX minus AP squared. Do not prove these equations. Part 1. Find the coordinates of U. The x-coordinate of U is 0 since U is a y-intercept, and U lies on chord PR. So the y-coordinate of U is found by letting x equal 0 in the equation of chord PR. Hence, y is equal to half times P plus R in brackets times 0 minus APR, which equals negative APR. Therefore, the coordinates of U are 0, negative APR. Part 2. The tangents at P and Q meet at the point T. Show that the coordinates of T are A times P plus Q in brackets, APQ. The equation of the tangent at P is y equals px minus AP squared, and the equation of the tangent at Q is y equals qx minus aq squared. So we find the x-coordinate of point T by solving px minus AP squared equals qx minus aq squared. In other words, we're equating these two equations here. So rearranging the equation to have the terms involving x on the left-hand side, we get px minus qx is equal to AP squared minus aq squared. Factorising out x on the left-hand side here and factorising out a on the right-hand side here, we get x outside of p minus q in brackets equals a outside of p squared minus q squared in brackets. Now we have a difference of two squares on the right-hand side, so the equation becomes x outside of p minus q in brackets equals a outside of p minus q in brackets times p plus q in brackets. Now dividing both sides by p minus q in brackets, provided p does not equal q, we get x is equal to a outside of p plus q, which happens to be the x-coordinate of point T in the question. Now to find the y-coordinate of T. We can use either of these two equations, substitute what we found for x here, or here, and then find y. So I'm going to use this equation here, y equals px minus AP squared, and I'm going to substitute a outside of p plus q in brackets for x here. So the y-coordinate of T is given by y equals p outside of a outside of p plus q, all in brackets, minus AP squared. Expanding the brackets here, we get y equals AP squared plus APQ minus AP squared. Now the AP squared terms will cancel and we're left with APQ. Therefore the coordinates of T are a outside of p plus q in brackets, APQ as required. Part 3. Show that TU is perpendicular to the axis of the parabola. It's given that QR is perpendicular to the y-axis, and this implies that QR is parallel to the x-axis. This means that the y-coordinates, or the heights of Q and R above the x-axis, are identical. In other words, AQ squared is equal to AR squared. Now moving AR squared over to the left-hand side and factorising out A, we get the equation A outside of Q squared minus R squared in brackets equals 0. Now A does not equal 0, so we can divide both sides by A, and then we're left with Q squared minus R squared equals 0. And we have a difference of two squares here. So factorising the difference of two squares, we get Q minus R in brackets times Q plus R in brackets equals 0, which means Q equals negative R, provided Q does not equal R. Hence, the y-coordinate of u equals negative APR, which equals APQ, if we substitute q for negative r here. And that's equal to the y-coordinate of t. Therefore, ut is parallel to the x-axis, which means it is perpendicular to the y-axis and the axis of the parabola.